Okay, and then finally for this last brief video here, I'm just going to go ahead and do a couple examples from the second page that you have. I'm going to do number 4 first. It says solve each equation by factoring. Well, it turns out that 1, 2, 3, and 4 are already factored. So at that point, what we do is we're just going to use the zero product property. So I can, again, if two things are being multiplied, A times B, and I'm getting a product of 0, right? Either one of those could be 0, and that would give me a solution. So I will just set 8p plus 7 equal to 0, and I'll also set p plus 7 equal to 0. One of these is really simple, right? P is negative 7. That's one solution. And the other one is 8p equals negative 7. Therefore, if I divide both sides by 8, I get that p is negative 7 over 8. So my two solutions are negative 7 and negative 7/8. Let's take a look at number 5. These 5 through, I think it's 10, say factor completely. This first one is the difference of two squares. And to factor the difference of two squares, it's pretty simple. This is just, of course, k minus 5 times k, oh, not x, times k plus 5. So whenever I see that, right, when I see that I've got a perfect square and a perfect square, and in between those I've got a subtraction problem, this pattern will always work. You can verify it by multiplying these out too. In fact, it might be instructive to do that. So if I multiplied these, you can see I've got the k and the negative 5. I'm going to put my variable in the upper left corner. And I've got the k and the positive 5. So k times k is k squared. Down here I've got negative 5k, and in the upper right I've got positive 5k, and then down below I've got the negative 25. So you can see what happens, right, when I have this minus and this plus. These guys end up canceling each other out. So that's why there's no k's in the original problem, because I've got a positive 5k and a negative 5k. So k minus 25, k squared minus 25 factors as k minus 5 times k plus 5. The other one that I set up to do was number 8. So on 8, I guess I'll just set up a generic area model. So in that, I'll go ahead and put my b squared in the lower left corner, and I'll put my 15 that's positive up here. I need to break up this negative 8b into groups, and they have to be two groups that have the same product as this diagonal 15b. So to help me organize that, I'll just go ahead and write the 15b at the top of this diamond problem. I'm sorry, 15b squared. And then down below here, I've got the negative 8b. So um, what are factors of negative 15 that are going to help me get negative 8? Well, I guess they're both going to have to be negative, right? Because I could do negative 3 times negative 5. That is positive 15. And when I add those together, I would get negative 8. So it looks like I'm going to break up the 8b as negative 3b and negative 5b. So I'll go ahead and put those in the area model, negative 3b and negative 5b. And it doesn't matter where they go, I'll get the same answer. So if I pull out the greatest common factor, I guess I'll do it first along this direction. Right, when I grab that, I am just getting a b. Right, so I'll just write a b down here. Well, if that's what I get there, definitely has to be a b below. And if there's this b below here and I've got a negative 3b, this has to be a negative 3. And if that's b, this and this ends up having to be the negative 5. And yeah, everything checks, right? You can see I've got b times b is b squared. I've got negative 5 times b, negative 3 times b, and negative 3 times negative 5 is positive 15. So the factored form of this would be b minus 5 times b minus 3. So this is exactly the same, right? These are equivalent. B squared minus 8b plus 15. That's the product expressed as the sum of the parts. And down here, b minus 5 times the quantity b minus 3. That's the area rather expressed as the product of the length times the width. Okay, 13, um, simplified radical form. If I look at this, I'm thinking about perfect squares inside of it, and it might be helpful just to jot down a list of perfect squares. So, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So a long list of these might help some. I'm just looking for perfect squares that I can divide my numbers by. 8, it turns out I can divide by 4. So I could rewrite this as the square root of 4 times 2x. And because the 4 is a perfect square, I'll break this up as the product of the square root of 4 times the square root of 2x. And again, because root 4 is a perfect square, I can now write this as 2 times the square root of 2x. So again, the 4, right, is the square root of 4 is the 2 that I'm looking at here. So my answer is 2 times the square root of 2x. And then the final example that I'll do with you is number 48. And as I look at the number 48, I'm trying to think in my mind. I think that's divisible by 16, and I know 16 is a perfect square. 48 divided by 16. Yeah, it's 3. Great. So I can rewrite this as the square root of 16 times 3v. And that's equivalent to the square root of 16 times the square root of 3v. You can definitely break up a root as to the product of these two parts. And then finally, the square root of 16 is 4, and the square root of 3v is root 3v. So my answer is 4 times the square root of 3v.